Hello students, I am Manoj Kundare, the Assistant Professor of Electronic Science. Welcome back to our e-learning platform. In previous video, we have seen the basic computer organization. In that video, we have also seen the concept of bus. The link of the previous video is available in the description box. Please check it. Now, in this video, we are going to see the detailed concept of the computer bus. Let's start our topic, the computer bus. The computer bus is the communication link used in computer system to send or receive data, address, control signals, and power to various components in a computer system. The computer buses are used to connect various hardware components that are the part of the computer system. That is, the computer buses are the electrical wires which connects the hardware components in computer system. The computer bus carries the data, control signals, memory addresses, and the power supply to these components. That means, in other words, we can say that the computer system is made up of the number of hardware components connected with each other. The hardware components like CPU, monitor, keyboard, mouse. These all hardware components are connected with each other through the electrical wires. Okay, these are the connections of electrical wire. These electrical wires carries sometimes data, sometimes control signal, or sometimes addresses. Okay, these electrical wires are known as the bus of the computer system. I hope you all understand what is meant by the bus. The bus is a communication link between the component of the computer system, that means between CPU and memory are connected with the bus, and this bus carries the electrical signals, control signals, memory addresses, and data. I hope you all now understand what is meant by the bus. It is a bus that connects all the internal components to the CPU and main memory. The size of bus, known as the width, is important because it determines how much data can be transmitted at one time. That means the data transmission or the amount of data transmission and the time required to transmit the required data. This factor is depends mainly on the width of the bus. That means if the bus has many number of parallel lines, then it can transmit large data in smaller time or minimum time. Okay, that means as the width of the bus increases, the data transmission time reduces. Okay, I hope you all understand this concept. That means what is the width of the bus and its effect in data transmission and data transmission time. The buses transfers data in parallel because in parallel we can quickly transfer data in very short time. In 32-bit bus, data are sent over 32 wires simultaneously. Every bus has a clock speed measured in megahertz. Now let's see what is the system buses. The system buses or the system bus is a set of wires that interconnects all the components or subsystem of the computer. That means a source component sources out data onto the bus. A destination component inputs data from the bus. That means both the source and destination transmit and receive data, that means inputs and outputs data through the bus, and we have seen that the bus is nothing but a number of parallel lines or electrical wires that carries data. Okay, it may have hierarchy of buses, address, data, and control buses to access memory and input output controller. Second set of buses from input output controller to attached devices or peripherals. Peripheral component interconnect or PCI bus is an example of a very common local bus. Okay. Now let's see the bus architecture of the CPU or the computer. Let's see the system bus here. In this system bus, we can see that there are three types of bus: control bus, address bus, and data bus. As per name implies, the control bus provides the control signals, address bus provides the address of the location, and data bus provides the data to be transmitted or received. Okay, if we see the diagram carefully, then we can see that the CPU is connected with control bus through a bidirectional arrow. That means the control bus is bidirectional. The data bus is also bidirectional, but if we see the address bus, then it is unidirectional, like this. I hope you all understand the difference between the control bus, address bus, and data bus depending upon its direction. That means the control bus and data bus are bidirectional, while the address bus is the unidirectional bus. Now let's see more details about these buses. First one, let's see details about the address bus. It is a channel which transmits address of the data, not the actual data, from the CPU to memory. That means the address bus transmits only addresses of the data. It is not transmit the actual data. Okay. The address bus consists of 16, 24 or 32 parallel signal lines. The number of lines or wires determines the amount of memory that can be directly addressed, as each line carries one bit of the address. If the CPU has n address lines, then it can directly address 2 raised to n address lines. That means if the CPU has one address line, then it can address 2 raised to n, means 2 raised to 1 equal to 2 address line. Similarly, it has 2 address lines, then it can address 2 raised to 2 4 address lines. Okay. Similarly, for example, if a computer with 32-bit address can address 4 GB of physical memory. The CPU reads or writes data from the memory by addressing a unique location. How? Let's see. Outputs the location of the data on the address bus. Memory uses these addresses to access the proper data. Each input-output device, such as monitor, keypad, etc., has a unique address as well. When accessing a input-output device, CPU places its address on the address bus. Each device will detect if it is its own address and act accordingly. This happens because each input-output device has its unique address. Okay, that means if we want to operate mouse, then CPU sends address of mouse, and the mouse has the unique address. The keyboard also has the unique address. Okay, I hope you all understand this concept. The devices always receive data from the CPU. CPU never reads the address bus because the CPU never addressed. Okay. Now let's see the second type of bus, the data bus. The data bus is a channel across which the actual data are transferred between the CPU to memory and input-output devices. That means the data bus is used to transmit the actual data. The data bus consists of 8, 16, 32 or 64 parallel signal lines because each wire can transfer 1 bit of data at a time. An 8-bit wire can move 8 bits at a time, which is a full byte. That means if a data bus is made up of 8 electrical wires, then it can transmit 1 bit at a time. That means in a single time it will transmit total 8 bits, and we know that the group of 8 bit is known as a byte. Okay, that means the 8-bit data bus can transmit 1 byte at a time. I hope you all understand this concept. The number of wires in bus affects the speed at which the data can travel between hardware components. The wider the data bus, more data it can carry at one time. That means if the data bus has more electrical wires, then it can transmit more number of bits at a time, hence its speed also increases. The data bus is bidirectional. This means that CPU can read data from the memory or it can send data out the memory. When the CPU fetches data from the memory, that means when the CPU gets the data from the memory, it first outputs the address on the address bus, then the memory outputs the data onto the bus. The CPU reads the data from the data bus. Okay, that means when the CPU fetches the data from the memory, first of all it outputs the address of this memory location on the address bus, then it receives or reads this memory location's data on the data bus. Similarly, when writing data onto the memory, that means when CPU want to write data into the memory, then CPU outputs first the address on the address bus, then outputs data onto the output bus. Memory then reads and stores the data at the proper location. That means when CPU want to store the data into memory location, then first of all it places the address on the address bus, then address bus selects the memory location, and the data placed on the data bus will be read and stored in the memory location, okay, whose address is carried by the address bus. The process to read write to input output device is similar. Okay, now let's see the third type of bus, the control bus. The physical connection that carry control information between the CPU and other devices within the computer. This bus is mostly a collection of unidirectional signal because it provides the control signals, and we know that the control unit is placed in the CPU. Hence, CPU only transfers control to the other hardware parts of the computer system. Hence, there is only one direction of the data transmission or the signal transmission. Hence, it is the unidirectional in nature. It is the path for all timing and controlling functions sent by the control units to other units of the system. It carries signals that report the status of the various devices. This signal indicates whether the data is to be read into or written out the CPU, whether the CPU is accessing memory or an input-output device, and whether the input output device or memory is ready for the data transfer. Okay, that means it carries the signal that report the status of the various device. That means it also used to check the status of the device, whether it is busy or free to transmit or receive the data. For example, one line of bus is used to indicate whether the CPU is currently reading from or writing to main memory. Others are input output, read write. I hope you all understand the three types of buses: address bus, data bus, and control bus, and their concepts. Thank you.